Hello everyone, welcome back to my channel. My name is Navdeep and today we will talk about Dataiku, which is one of the tools for doing data science, ML and deep learning work. And I'll show you how to create data science pipeline in Dataiku, put a model on top of it, and how to evaluate the outputs. So on my screen, this is pre-built data science pipeline which I have built before starting the video, but don't worry, I'll just show you how I have done that. So first on the data side, so if you click on the data, you can see what kind of data it is. So in this data set, we are trying to predict if a patient will have diabetes or not. And this is the class variable, which is target variable, and based on the type of problem, it is something which is a classification problem. You are classifying if a person will have diabetes or not, 0 and 1. And the independent variables, or I would say predictors, are number of times pregnant, plasma glucose concentration, blood pressure, skin, insulin, body mass index, diabetes, pedigree function, and age. So these are some of the predictor variables, and this is the target variable. Now coming back to data IQ, I just wanted to show you some of the features of data IQ before starting and before getting deep into the flow. So this is the data IQ, and if you click on the test, you will go back to this screen where you are seeing that uh, it will show you how many flows are there in a flow, how many data sets, model, recipes, and notebooks, dashboards, wiki, and tasks are created, right? We'll go to the flow, which brings us to this particular screen, and on top you will see a few quick links to go to different options. For example, this one is go to flow, dataset, and recipes. This one is for visual analysis, notebooks, web apps, R markdown reports, library. So notebooks are something like you can launch a Jupyter notebook from notebooks, uh, do your EDA, and do your understanding of the variables, and come back and create a recipe here. Right side, this play button is where you can create look at the jobs. So jobs is like when you are running this pipeline, there might be some errors happening. You can come and see on the jobs the status of the errors. Scenarios are something like trigger based tasks. So for example, you have, let's say, 5 different steps in your flow, and you want to run them one by one based on the condition, so you can put that in scenario. Automation monitoring is for automation. Wiki is if you want to add some commentary about the flow, you go to wiki and add. And then is the dashboards and insights. If you want to create any dashboard on top of the data, you can do that here. And if you click on these three dots, you will find few more options. So one of the option I would like to highlight is variables, where you can uh, declare few of the global variables, and you can utilize those variables in the flow. Alright, so now coming to the flow. So this is these blue boxes which you see, these are actually data sets, and this one is a direct upload, whereas these two blocks which you see, these are S3 files, and the yellow ones are recipes. So in Dataiku, after every recipe you will have to store that data somewhere. That could be like you are storing it during the runtime in the memory of Dataiku, or you are storing it on some external data repository, some such as S3 or Redshift. So in this case, I'm using S3 to store those files. And if you want to look at the recipe options, you click on any of the data source, and on the right side you will see all the recipes which are available. Some of these are like very generic visual recipes, but some of these are more custom and code based recipes. Now let's get into the data. So on the data side, we have looked at the data, and it looks like everything is numeric. There is no categorical variable, so you don't have to do any label encoding or any variable encoding. So we are good with that. Coming back here, so what we have done here is that we loaded the data. We have done a bit of cleaning, right? We are just trying to remove one of the column here which actually not needed, so I can just remove this particular check. I'll just delete this step, okay, and I'll run it. So what run will do, run will update the data set and will load the updated data set into S3. So this the small green icon here, it is telling that the job was in progress, and now right side you see the notification that job is completed. So the data is loaded into this particular data v1 prepared S3 folder, and now this recipe is split recipe where we are splitting data into training and testing. So first set is train where we are loading the 70% of the data, and then comes the predict where we are loading 30% of the data. Well, you can add one more data split here based on, like, if you are keeping some data for holdout, probably 10% or 15%, you can do that. Now since I had recreated the earlier recipe where we added one column, so I'll have to run this recipe as well, so just to make sure that that new added column is flowing to the downstream recipes. Now this notification is telling me that there is a change in the schema. So schema in Dataiku, schema is like a table. So there is a change in the table. It was expecting 8 columns, but it is getting 9 columns now because we added one more column. So we'll have to click on update schema, which will basically update the table structure. Coming back to the screen, so now we have updated data in the train folder, and then similarly in predict we'll have to run this recipe. We are running this recipe, and what we are doing here is that we are removing the class variable because we can't have class variable in the predict dataset, and the ML model will try to predict the class variable in the predict recipe. So on the top part is for predict, bottom part is for train. Just to get the sense of the data, it is again similar data in the train. It's just that you are still passing the class variable for model to train on the data. Now I'll come back to the recipe. I'll click on train, and on the right side I'll see all the recipe options. I'll have to go to lab. So lab is where you will find your ML models. Now you click on lab, you see new analysis, AutoML prediction, deep learning, AutoML clustering. So in this case, because it's a ML problem, we will click on AutoML prediction. In AutoML prediction, you will have to first select the target variable. In this case, we are looking at class variable, which is the target variable. Now once you have selected that, you'll have to give name to your analysis, and you can give it whatever you want. I am giving it demo Dataiku. Now here the options are, you can do a quick prototype, which is get some models generic and quick, right? You can do that. You can do an interpretable model where it will use some very easy and simple models which can be explained to the business users in more business friendly terms. Or you can do the high performance models such as XGBoost or boosting and bagging based algorithms. Well, if you are expert and you don't want to use AutoML, go to expert. You can select deep learning, or you can choose your own algorithm, right? So just for keeping it simple, right? Let's just go with the high performance models, and let's see how AutoML is being used here. So I'll click on high performance models. Let's just click on create. So it is saying that there are 3 algorithms and 8 features selected. All right, now let's just click on train, and you see the features of Dataiku here. At a given point of time, it is running 3 different models: random forest, logistic regression, and XGBoost. And it is showing you in real time how these models are improving. So what is the change in the ROC? So it is like doing the hyperparameter tuning, and showing you if there is an improvement in the ROC AUC or not. And if you scroll down here, you will see all three models listed and the hyperparameters of those three models, plus the trained set, test set, and the train time, some of the statistics around the data. And then you will have the list of features which are like the top features in the model. For example, if you look at this one, right? So this is your logistic regression. So plasma glucose concentration is one of the top feature. Then comes the body mass index, diabetes, pedigree function, times of pregnant, age, and skin. Similarly, if you look at XGBoost, here again similar setup, most important features, hyperparameters, and some of the statistics around the model, train time, test, and train split. Now, I know we as a data scientist, we do all of these things in our Python notebooks or some other programming language. But if you look at Dataiku, it has made it very simple. It is straight away pulling few of the classification models, running it, doing the hyperparameter tuning, and giving you the metric. Now you can change that metric from AUC ROC to precision recall F1 or any other metric, right? Which is definitely very easy, and you don't have to even do a single line of code. It is doing everything for you. Now out of these three model, it is saying that okay, logistic regression has done highest in terms of accuracy. Now let's just switch to ROC AUC. In terms of ROC AUC, your random forest is doing great. So now let's just keep AUC ROC as one of the key metric. Now let's look at random forest in detail. Now here you will see all the metrics which are needed, such as your interpretation, performance, model information. Now in interpretation, if you want to see the tree structure, it will show you that which is your um, your node, the split node here, parent node, and how it is further being split into different conditions. And you can actually expand this decision tree, right, to see how it is splitting and how it finally reached to the leaf node. Variable importance will show you how the variable importance is looking. Partial dependence plot is again one of the important feature which comes under explainable AI. We'll talk about this in some other session. Similarly, you can have subpopulation analysis, individual explanation, where you can look at the Shapley values. Now on performance, you can see confusion metric, decision chart, lift chart, calibration curve, and all of those things. All right, so once you have validated your model and you feel comfortable with the model, let's deploy that. You click on the deploy. This is your trained data set, this is your model name, and create. So it will automatically add these two recipes to your flow. One is your train test split, another one is your model. Now once you have the model, you would want to export you would want to use this model to basically score your prediction data, right? Now to do that, click on the model again, right, and then go to recipes. You will find that there is a recipe called predict, right, which can be used here. So you click on the train object, right side you see that predict recipe. Now click on predict, select the input data set, select the output data set, right? Now everything is already selected, and let's just in the prediction model, definitely you have to select the model. Once it is selected, create recipe. So it has created the recipe. Now you can just run it and it will start scoring your train data. sorry, your predict data. So one thing, the incorrect thing which I have done here is that I have used train data as the input for the mod for the scoring uh, recipe, right? Let's just change it. Go to input output, change, don't select train, select select the predict one, right? And then save it, and let's go back and let's run it. And even I think we don't have to select actually predict, we should select the split prepared because that's the final data set, right? Let's just change it. Good, it's a learning for us. Okay, update the schema. Let's go back and let's now what it will do, it will score the data set and it will write it to the train scored output. We have to save the evaluation metrics as well, right? So what we will do, we will pull another recipe which is called evaluate. Right now in evaluate, you need to give the input and the output data sets. So we are going to evaluate on the train data set. Prediction model is this one, and in metrics, like you have to set the data set where you want to store the metrics. Now let's just call it demo metrics, right? And we created the data set and outputs, let's just call it demo set. We created the data set and then we create the recipe and we run it. So here we go. So we have our model created, we have the evaluation metric, this one, and then we have our scoring recipe which is saving the scored outputs to the train scored. And just to look at the evaluation metrics, right? If you click on demo metric, you can see that date, precision, recall, AUC, everything is stored in the file. So you can write this to a table or you can write this to any flat file. And then if you look at the demo set, it will show you that what was the class variable, what was predicted by the model, right? This prediction column, and then was it true or false, and then it will show you the probability of true and false here. Let's go back, and this is our score data set. All right, let's just build it again. Okay, so what happened, we didn't run the recipe, so we didn't have the final outputs in the recipe, but it shouldn't take time. So you see job is completed, and if I come to the data set, I should be able to see one column which is called prediction, which is telling if a person will, based on the attributes of if a person will have diabetes or not. Now looking at the flow, you can understand that Dataiku has made it very simple to create an ML model and to train and predict a ML model, to create a history of the ML model for audit and governance. Because when we used to do this using Python or any other language, it was difficult to keep a track of your multiple iterations which you are doing on model. Now good part here is that if you come to the model, you can actually see all the earlier versions of model which you might have used. Now this one is because we had used just one model and trained just on one model, but let's say we are training it again, right? So it will keep the history of all the earlier model performances. So I'm training it again. Now you will see there is a history maintained. Okay, so you see this one was the older one. Now it is training another one and it will save that model here. So these are few of the basic concepts of building a data science pipeline in Dataiku, and I wanted to share this with all of you. Let me know if you have any question on the flow or as such on the ML part of the thing. I can go in more detail and I can respond to you via comments. Thank you and happy learning.